Use the diagram for all it's worth. Draw a diagram, and finally, don't make up your own problem. And if you're looking at this video, you should have already tried to do the problems that were attached. So for the first problem, if the length and width of a rectangle are both tripled, the ratio of the area of the original rectangle to the area of the enlarged rectangle is, and you have to figure that out. There's more than one way to do this. One way to do this would be to draw a diagram. So you might draw a diagram of a rectangle. But whether you draw a diagram or not, I think plug-in numbers would be a great idea. So let's say that the width of the rectangle is 2 and the length of the rectangle is 5. Okay? So with that information, you can calculate the area of the original rectangle would be 10 square units, whatever the units are. If I triple the sides, the 2 in my new rectangle is going to be 6. It will be 6 by, if I triple 5, I'll get 15. And 6 by 15 would give me 90 square units, whatever the units are. And that is 9 times the original area, and so the ratio is 1 to 9. So I worked that out, and I am sure of my answer, so I'm going to mark an S in the margin. Next problem. At a luncheon table where 12 men are seated, 1/2 of the men belong to Club A, 1/3 belong to Club B, and 1/4 belong to both clubs. How many men belong to neither? So I've seen people do this a number of ways, but for me, the easiest way to do this is to draw a Venn diagram. So here's my Venn diagram. I have Club A and Club B, and they do intersect. I know there are 12 men altogether. Half are in A, 1/3 are in B, 1/4 belong to both clubs. Aha! 1/4 of 12 is 3, so there are 3 guys in here. 1, 2, 3. Okay. Half the men belong to Club A. Half of 12 is 6. 3 are accounted for, so I need 3 more over here. So 1, 2, 3 are in A but not in B. And then 1/3 belong to Club B. 1/3 of 12 is 4. 3 are already accounted for, so there must be 1 more member of Club B who is not also in Club A. So how many belong to neither? Well, let's see how many belong to either A or B or both. That's 1, 2, 3, 4, 5, 6, 7. So there must be 5 out on the perimeter of that part of the diagram, so the answer is 5. And again, I am sure of my answer. I'm going to mark that with an S. Last one on this page. In December, Elizabeth sold 30% more satellite blah blah blah. In January, 20% more than in December. The number of satellite TV subscriptions was what % greater in January than in November? Okay, so we have November, December, and January. When I see %, I always like to plug in 100. So let's say that she sold 100 in November. Then she sold 20% more, well, 30% more in December than in November. So 30% more than 100 would be 130. And then she sold 20% more in January than in December. This is the only computation I really have to do. 20% is 2/10. So 130 times 2/10 is 26. So 26 more would make it 156. And so the number of satellite TV subscriptions she sold in January compared to November is what percent greater? 56% greater, and I'm sure again. Okay, now let's get to the other side. So that was the plug-in number strategy on that last one. Number 4, the weight of a bag of mangoes plus 4 more than twice that weight equals 40 pounds. How much in pounds does the bag of mangoes weigh? Okay, so I know a lot of you are going to want to let x equal the weight of the bag of mangoes and write an equation and solve the equation. And that's a perfectly valid way to do the problem. I just think it might be quicker to use the strategy try the answers for this one. So if I'm going to try the answers, I usually like to start with the middle value and see if that works, because usually I'll be able to tell whether I need to go higher or lower. So 14, the weight of the bag of mangoes, plus 4 more than twice that weight, plus 4 more than twice that weight, is that equal to 40? So 2 times 14 is 28, plus 4 is 32, plus 14, no. Okay, that didn't work. Can you see why it's good to start in the middle? Because I believe that I can tell now that that's too big. So the next one I'm going to try is 12. So 12 plus 4 more than twice 12, and we want to see if that's equal to 40. So this is 24, 36, 40, ta-da! The answer is 12, and I'm sure because I've already checked it in the problem. That's one of the nice things about trying the answers. Okay, number 5. This triangle is isosceles and drawn to scale, and we're supposed to find the measure of angle N. If it's isosceles, the base angles are congruent, and so whatever the measure of angle N is, that's also the measure of angle M. So if I call that x, I know that x plus 22 is 180. So 2x plus 22 equals 180. So 2x equals 180 minus 22. That's 158. So x equals 79, and the answer is D. So far we've used try the answers. We did that on number 4. We used plug-in numbers earlier, and we used the diagram for all it's worth. We drew a diagram for 2 of them. So far you haven't seen an example where you shouldn't. Sorry, had a little problem with the battery there. I'm going to start number 6 again. Number 6 is an example where the strategy is don't make up your own problem. So it reads like a system of equations for you to solve, and I would urge you not to use that approach, but instead to focus on the question that's asked in the problem, which is to find x plus y. In other words, nobody asked you to find what x equals and what y equals. It's their sum that we're interested in. So I understand from lots of experience that the problems on these tests are often rigged so that you don't have to do elaborate computation if you really understand what's going on. And what's going on here is that you need to take a good long look at the 2 equations. I'm going to use this space up here. So x plus 2y equals 1, and 2x plus y equals 5. And I'm interested in x plus y. When I look at this, I just can't help seeing that I have 3x plus 3y on the left-hand side, which is 3 times the quantity x plus y, and there's my x plus y that I'm after for the answer. So 3x plus 3y would equal the sum on the right-hand side, which is 6. And so x plus y would be what I get when I divide both sides by 3. So x plus y equals 2. And there's my answer. And I am sure. That's it for this. Thanks.